I'm Jerry Lobdill. I'm a retired physicist and chemical engineer. I have a BS in chemical engineering from Texas Tech, and I have extensive coursework in mathematics and physics from the University of Texas at Austin. I've had broad experience in analysis and applied research, 30-year professional history spanning physics, chemical engineering, statistical analysis and modeling, and operations research. Most of my work over the years was classified defense work, and in my retirement years I've been devoting time to continued problem solving in areas that I find of interest. I began work on the World Trade Center collapse matters in 2006 after I read Stephen Jones's paper in which he reported on the presence of the iron-rich microspheres. I had some ideas about the microspheres that made me want to write a paper on it. I did write a paper, and in July of 2007 it was peer-reviewed and published in the Journal of 9/11 Studies. So one of my problems here was, what about these microspheres? What could produce them? Why are they important? Well, they're important because they are ubiquitous in all World Trade Center dust. They're not found in remains of fires. They might be a marker proving controlled demolition, and there was no available explanation of them at the time that I started this work. So what do the microspheres contain? Iron is the main element, and then it has smaller portions of aluminum, sulfur, a trace of manganese, a trace of potassium, and there may be a few other small concentrations of other items. Some of these microspheres are hollow, and that's consistent with beginning as droplets of iron with some sulfur inside of them that would be gas at the temperatures of the droplets. Here are some interesting things about the microspheres. They're really small. Most of them are less than about 1/10 of an inch in diameter, and they're spherical, and they're found in all of the dust blown out of the buildings during collapse, no matter where in Manhattan that dust is picked up. Some of them are hollow with traces of sulfur inside, and that's consistent with gaseous sulfur at the temperature of the molten iron that these spheres are made out of. The sulfur that's in the mixture is a gas, and so if a microsphere or a little bit of droplet of iron, molten iron, is produced that has sulfur in it, it tends to produce a hollow sphere. And then when the temperature decreases and the microsphere becomes solid, the gas sulfur becomes dust, and it's deposited on the inside of the microsphere. Thermite is a mixture of aluminum dust and ferric oxide in specific proportions. I concentrated on the iron oxide in my paper that I produced, so I'm going to talk about the iron. The iron oxide and aluminum produces a very, very hot iron that is molten, and when it comes in contact with steel, it melts it rapidly. The steel melts at about 2,800 degrees Fahrenheit, and thermite heats steel to about 4,530 degrees Fahrenheit. Now I want to talk a little bit about thermate. Thermate is made from thermite, and the way it is made, you add 31.4% by weight of sulfur into the mixture of thermite, and that becomes thermate. And the reason thermate is of interest to us is because it lowers the melting temperature of the steel to about 1,821 degrees Fahrenheit, and that helps in getting the columns melted quicker. So apparently that was the reason why sulfur was used. In the World Trade Center 7 situation, FEMA even found sulfur in steel, and they didn't understand what it was doing in there, and their report mentions that it was a big mystery as to why it was in there. Well, it was in there because it was thermate that was used to melt that particular piece of steel that they were testing. Also, there's a government theory that calcium sulfate from gypsum boards was the source of sulfur, and that's wrong. Calcium sulfate cannot undergo any kind of a chemical reaction that produces the element sulfur, and we're not dealing with any kind of compound of sulfur. When we're talking about sulfidation, we're dealing with the element sulfur. And basically what happened with those gypsum boards is the same thing that happened with the cement in the floors of the World Trade Centers. They were pulverized and blown out of each story as it was destroyed. That World Trade Center 7 steel that FEMA tested looked like a piece of Swiss cheese after it came out of the World Trade Center. It was twisted up and looked like Swiss cheese. The FEMA report also mentioned intergranular melting and sulfidation of the steel, and that's not consistent with any kind of regular fires, any kind of fires from fuel or other things that might be burning. You have to have an extremely hot fire for this sort of thing to happen, and you certainly are not going to get any melting, no intergranular melting, unless you have something much hotter than a regular fire. The only thing that is consistent with all of the evidence that we have that could cause such a thing is the use of thermate to cut through the steel. One of the other things that I needed to do in connection with my paper that I wrote was I had to find a way to estimate the temperature of flames and the material that was coming out of the 80th floor of the World Trade Center. And what you use to do that is called black body radiation. It's a very mature technology, and this is how we know what the temperature of hot objects is. When you have an orange-red color, such as the colors of the fuel that was burning right after the crashes, that temperature is in the range between about 1100 degrees and 1800 degrees Fahrenheit. If you have thermate is going to be at 4500 degrees, or thermite would be 4500 degrees. And it produces melted iron that is white hot. And so when you see in the video the white hot material coming out of the World Trade Center building, that cannot be anything but a thermite type reaction. Some people have said that perhaps that material was molten aluminum. There's a big problem with that. When aluminum melts at a very low temperature, it does melt at a very low temperature compared to steel. And when it melts, it does not glow or radiate a color. It looks just almost like it did when it was a solid piece of aluminum. It's just a silver colored liquid. And so you can't get that very white hot color with aluminum at all. Now, why do you think thermite might be used in the destruction of the World Trade Centers? The reason is that columns must be cut with cutter charges before the high explosive demolition choreography is applied to assure the proper symmetric collapse. At the bottom, these columns in the center are about they're box columns, they're box beams, and the steel is about 4 inches thick. We have reports from eyewitnesses that they heard explosions, and we found molten steel in the basements of these buildings. This comes from cutter charges, and you have to do that before you can demolish each floor, because when you use the high explosives to blow out the material that's on the floor, you can't afford to have any of those columns remain standing, because they will apply angular momentum to this material that is falling on top of them. So you have to have them cut well, and that's why you need to use thermite. Some folks have thought that perhaps another reason to use the thermite is that thermite is not as loud in doing its cutting as for example, a shape charge of RDX might be. So it doesn't create a large loud explosion. I'd like to talk a little bit about the difference between high explosives and deflagration. A lot of people, almost everybody, thinks, for example, that when you shoot a gun that you're getting an explosion. Well, it's not really an explosion. It's a deflagration. What it does, the energy, it's very loud, of course, but it pushes the bullet out of the gun. So there's a range of things that we ordinarily call explosions that are really deflagrations. And when you have a high explosive like RDX, the kinds of things that I would imagine were used to blow out the contents of the floors, those kinds of things have burning speeds that are like 27,000 feet per second. And when you're talking about thermite, you're talking about something, an order of magnitude less speed, and it's more like a deflagration than it is an explosion. So all of these things that I've been talking about were contained in this paper that I wrote and published in the Journal of 9/11 Studies. And there's not a single thing in my paper that supports the NIST theory. When we're talking about thermite, we're talking about an incendiary. And as I mentioned before, it's more like a deflagration than an explosion. But much of that research is classified. Civilian knowledge and research is tightly guarded, and demolition experts know much more than they are saying about this. If you look at the patent filings, there's much interest in thermite type cutters, so that's incendiary research is something that we really need to take into account. So when you consider that on 9/11, 3 steel frame buildings were destroyed, and they fell symmetrically. Each one of them fell symmetrically and produced a debris field that was symmetric. It boggles the mind to imagine that 3 of those things like that could happen when before that there had never been a collapse of a steel frame building at all. Not a single one anywhere, and there were plenty of fires of steel frame buildings where the building survived and was refurbished. So to find that 3 of these things collapsed in the same business complex on a single day, that's statistically impossible. After doing this paper, I come to the conclusion that thermite or thermate, and I'm sure that thermate was also used, or maybe it was exclusively used, those were used to destroy the World Trade Center buildings in some form or another. There were probably high explosives as well. And the physical chemistry of everything that I wrote about is consistent with no other hypothesis. And all of the testimony of eyewitnesses, all of the video evidence supports only controlled demolition as the cause of all three World Trade Center buildings' destruction.